I am Pavagada Manjunath, lecturer in physics. In this video clip, I am going to give solutions for 2nd PUC Karnataka Physics question paper 2014. My phone number 9886172298. Here, I am also going to explain how marks are going to be allotted for answers by taking the scheme of valuation given by Karnataka Pre-University Education Board. Here I am going to discuss answers for the questions in March 2014 Karnataka Physics question paper. In my previous video clip, I have explained about the timing and time management and also general instructions. Here I am going to discuss answers. Part A, answer all the following. Each carry 1 mark. So here these are the 10 questions. The first one is write the SI unit of charge. The answer for this one is Coulomb. Look here, this is the answer sheet and student has to write the correct question number and he has to answer. For 1 mark question it is enough to write one word or one sentence. Even the Coulomb is represented by C, therefore it is enough to write C, you will get 1 mark. Therefore for this one Coulomb or C is the answer. It is not necessary to write both of them, just one is enough. Even if he has written both of them, you will get mark, no problem. And the second one, it is define mobility of electron. So here for the second one, the answer is it is the drift velocity acquired by free electrons per unit electric field. The third one, look here, what is the nature of force between two parallel conductors carrying currents in the same direction? Both the currents are in same direction, therefore the answer is attractive force. The fourth question, look here, draw the pattern of magnetic field lines for a bar magnet. Look here, for the fourth one you have to draw the pattern. Look here, these are the magnetic field lines. First student has to draw this magnet, and it is important to mention this north pole and south pole. Look here, these are the field lines, they are closed loop. So these arrow marks are very important. If arrow marks are not there in this pattern, you will not get any mark. Next it is the question number 5. Give the expression for energy stored in inductance coil carrying current. So the answer is this one. This is the expression. Here for 1 mark it is just enough to write the expression to get 1 mark. And of course it is better to have the practice of explaining these terms. That is, L is self inductance and I is the current. For 2 mark questions, expression is required and also explanation is required. For 1 mark it is enough to write this expression. Next let us go to the sixth one. Look here, how is RMS value of voltage of AC is related to peak value of voltage? So for this the answer is Vrms is equal to V0 by root 2, where this V0 is peak voltage. Look here, this is how we can write the answers. And one more thing I would like to reveal, that it is not necessary to write in the same order. You can change the order also. Even you can write first 5 mark questions or 2 mark questions and then 1 mark question, like that also. So for the valuator, the board provides a scheme of valuation. Let us see that scheme of valuation. It is like this. Look here, Government of Karnataka, Karnataka State Pre-University Education Examination Board, second year PUC examination 2014, scheme of valuation. Look here, subject code 33, this is for physics. And look here, for first one, the answer is Coulomb or C, the marks awarded is 1. Second one, definition, marks awarded is 1. And look here, it is defined as the magnitude of the drift velocity per unit electric field. Or even the student can write the definition in the form of mathematical form. That is mu is equal to drift velocity divided by electric field. And look at third one, attractive. Just even if he has mentioned attractive, he gets 1 mark. Look here, the fourth one, this is the pattern. Like this, in the valuation center, every valuator is provided with this scheme of valuation. According to this scheme, they value, they give number. So now let us go to the next question, that is seventh one. So look here, the seventh one is what is wavefront of light waves. So it is seventh one, wavefront is the locus of points of constant pace. Next it is eighth one, that is state the radioactive decay law. Statement is required. For the eighth one, rate of disintegration of radioactive substance at any instant is directly proportional to the number of atoms present in it at that instant. Of course, this at that instant is also very important. It carries 1 mark. And next it is the ninth one, that is write the truth table of logic or gate. So we know the truth table. Look here, these are inputs A and B, Y is the output. So for 0 0 it is 0, for 0 and 1 it is 1, for 1 0 it is 1, for 1 1 it is 1. For OR gate, output is 1, for any one of the inputs is 1. Next it is the 10th one. So look here, give the bandwidth of TV signals for transmission. Bandwidth is required. And look here, the bandwidth of TV signal is 6 megahertz. So this is about part A. Now let us discuss part B. That is answer any 5 of the following questions. Look here, 1, 2, 3, 4, 5, 6, 7, 8 questions are there. Answer any 5 of the following. Each carry 2 mark. Look here, the 11th one, state and explain Coulomb's inverse square law in electrostatics. So the statement is like this: the force between 2 point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. The direction of this force is along the line joining the two charges. In this statement, this point charges, this is important because Coulomb's law is applicable for point charges. And this direction is also important because Coulomb's law gives both force, magnitude of the force, and also direction. Next, it is explanation. Explanation means from this we get this formula. So here F is the force between two charges, Q1, Q2 are the magnitudes of the point charges, and D is the distance between charges. Epsilon naught is the absolute permittivity of the free space. Of course, here you can draw the diagram also, relevant diagram, but that does not carry any mark. So look here, the scheme of valuation is like this. For the statement, 1 mark, and for the explanation, 1 mark. So next, the question number 12. Look here, draw Wheatstone's bridge circuit and write the condition for its balance. For this 12th one, this is the Wheatstone's bridge. P, Q, R and S are 4 resistors connected in the form of quadrilateral. And of course there is a galvanometer. So here you have to mention this arrow marks, that is currents. Through this branch current I1 is flowing in this direction. Through this branch it is I2. this I1 minus Ig. Of course, Ig is the current flowing through this galvanometer. This minus this gives this I3. That is I1 minus Ig. Look here, Ig plus I2 together gives I4. That is I4 is equal to I2 plus Ig. So here mentioning these arrow marks, the currents, very important. So for this circuit diagram, 1 mark is allotted. And the condition at balanced condition, through this galvanometer current becomes 0. To Ig to be 0, the ratio P by Q must be equal to R by S. This is the condition. That is Ig is equal to 0 or P by Q is equal to R by S. So for this 1 mark and for this another mark. Let us see the scheme of valuation. Look here, it is P, Q, R, S. Condition is P by Q is equal to R by S. If instead of P, Q, R, S, it is taken R1, R2, R3, R4, then it is R1 by R2 is equal to R2 by R2 by R4, like this. So both of them is not required, but any one of these two circuits and condition has to be written here. Look at this, circuit carries 1 mark and this condition carries 1 mark. Next, it is 13th question. Look at what is magnetic susceptibility, for which material it is low and positive. So look here, the 13th question, magnetic susceptibility. It is defined as the ratio of magnetization to the magnetic intensity. It is low and positive for paramagnetic material. So these two, as this is 2 mark question, 2 points are required. Next, it is 14th one. Look here. Mention any 2 advantages of eddy currents in the practical applications. So look here, 14th, eddy currents are used in magnetic braking in trains, induction furnace. So 15th one, let us see the 15th question. Who predicted the existence of electromagnetic waves? Give the wavelength range of electromagnetic spectrum. Look here, for this one, Maxwell predicted electromagnetic wave, and the range is 10 to the power of minus 14 meter to 10 to the power of 7 meter. So next, it is the 16th one. Of course, 1, 2, 3, 4, 5. 5 questions are over. Only 5 are required to answer. If you know answer for these choice questions, they can also be answered. But it is better to answer after answering all the questions in the all the required questions in the question paper. But I am going to answer it now. Look here, the 16th, that is explain Malus law of polarities. So look here, Malus law is I is equal to I naught cos square theta. Here I is the intensity of light emerged from polarizer, that is the first polarized. I naught, it is the intensity of light emerged from the analyzer, that is second polarized, where theta is the angle between pass axis of polarizer and analyzer. So here this formula carries 1 mark and this explanation for I naught theta carries another mark. So now the question number 17. Let us see what is 17. Look here, write any 2 types of electron emission. 17. Look at number 1, thermionic emission, field emission and photoelectric emission. Look here, it is just enough to write any 2 emissions because it is 2 mark question. For 2 points you get 2 marks. Even if you have written, even if you write this third one, no problem. But evaluator considers only 2 points. Of course, it is better to write one extra because somewhere if it is wrong, then evaluator will consider this one. You will get 2 marks. Next, let us see 18th one. So Look here, why there is need for modulation. What is the necessity of modulation? So we know need for modulation, number one, to reduce the size of the antenna, to increase the effective power radiated by antenna, to avoid mixing up of signals from different transmitters. Look here also, as this is 2 mark question, any two of them is enough. Now the 19th one. So look here, this 19th one is there in part C. Look here, part C. Answer any 5 of the following questions. Look here, 1, 2, 3, 4, 5, 6, 7, 8 questions are there. Answer any 5. So better you answer for any 5 of these. Look here, the 19th one, derive an expression for potential energy of system of 2-point charges in the absence of external electric field. So of course here each carry 3 mark. So expression for potential energy of system of 2, not 2, it is 3 point charges. So now let us consider this is the system of 3 point charges Q1, Q2, Q3. These two are separated by R12, these two are separated by R23, and these two are separated by R13. So imagine the charges Q1, Q2, Q3 are initially at infinity. Let the charges are brought from infinity and assembled as shown in the figure. Of course, in the beginning, all these are at infinity. Work done in bringing the charge Q1 from infinity to the point A is 0. Look here, to bring this one from infinity to this point, no work is required. This is because there are no other charges to oppose it. And look here, work done in bringing the charge Q2 from infinity to the point B is given by, look here, Q2. To bring this one from infinity to here, work has to be done because this charge is already there. This opposes its motion. And now it is given by W12. W12. 1 over 4 pi epsilon naught Q1 Q2 by R12. This is the distance R12. Next, work done in bringing the charge Q3 from infinity to the point C is given by, look here, W13 plus W23. Two works are required. This is because, so this Q3 is brought in the vicinity of Q1 and Q2. These two charges oppose the charge Q3. Therefore, work is done against opposition of this one. It is given by W13, and opposition of this one, it is given by W23. That is 1 over 4 pi epsilon naught Q1 Q3 divided by R13 plus 1 over 4 pi epsilon naught Q2 Q3 by R23. Now total work done in assembling the three charges is given by W is equal to this plus this plus this, and this is equal to this much, this thing plus this thing, and here 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught common. Therefore the total potential energy, it is represented by U is equal to 1 over 4 pi epsilon naught, take common, and here Q1 Q2 by R12, Q1 Q3 by R13, Q2 Q3 by R23, like this. So this is an expression for potential energy of system of three charges. So now let us discuss answer for 20th one. So look here, this 20th, write three uses of cyclotron. So look here, it is used to also accelerate the charged particles. This is the only use of cyclotron, but these accelerated charged particles are used further like this. The accelerated charged particles are used to synthesize new materials, to produce new materials. Next, the accelerated charged particles are used to produce radioactive material for medical diagnosis and treatment. Here, as this is 3 mark question, 3 points are required. Now it is 21st one. Look here, the 21st question. what are magnetic declination, magnetic dip, and horizontal component of Earth's magnetic field at a place. So look here, magnetic declination. It is the angle between the geographic meridian and magnetic meridian. Magnetic dip. It is the angle between the Earth's total magnetic field and its component along the horizontal at a place. And horizontal component of Earth's magnetic field at a place. It is the component of Earth's total magnetic field along the horizontal direction at place. Look here. So definition for this one carries 1 mark, for this another mark, for this the third mark, like this. And next it is the 22nd one. So look here. So third one, this state and explain Lenz's law for induced EMF. So now look here, this is Lenz's law. First 22nd, consider this is the north pole of the magnet moving towards the loop. This loop, this is the loop of a conductor. When it moves towards EMF is induced, that EMF induces current. That current produces magnetic field in it. So that the face towards this magnet acts as a north pole. This opposes motion of this one. If this north pole is moved in this direction, then that induces EMF and current in the opposite direction, so that it becomes south pole. The face becomes south pole, and this south pole opposes motion of the north pole away from the loop. So this is Lenz's law. So look here, when north pole of bar magnet is moved towards the coil, EMF is induced in the coil. This induces current in the anticlockwise direction through the coil, so as to generate north pole. This opposes the movement of the magnet. When north pole is moved away from the coil in figure 2, the EMF induces again. This induces the current in the clockwise direction through the coil so as to generate south pole. It opposes the movement of the magnet. So this is the 22nd one. Here the marks allotted like this. Look here, for this statement, the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces it. For statement 1 mark is there, and for figure and explanation 2 marks are there. So next it is the 23rd one. Look here, the 23rd, this is explain the construction of transformer, mention its principle. So here, look here, this is the transformer, diagram of the transformer, and look here, this is the primary coil, this is the secondary coil. It is called, here input is given, here output we are going to take. So this is step up transformer construction. Transformer consists of two coils insulated from each other, this one and this one. They are wound on a soft iron core. Look here, this is the soft iron core, and separate limbs. This is one limb and the another limb of the core, or either one on top of the other. Of course, they can also be wound one above the other. They are called primary and secondary coils. Look here, this is primary coil, this is secondary coil. In a step-up transformer, the primary coil consists of few turns when compared to turns of secondary coil. It is just opposite in step-down transformer. Look, in a step-up, number of turns in the secondary is greater than number of turns in the primary. So its principle is mutual induction. Look here, for this marks is allotted like this. So for this explanation 2 mark, and for principle 1 mark. So it is for this figure and explanation 2 marks, and for this one mutual induction, the principle 1 mark. Now let us go for the 24th question. So that is Mention three applications of total internal reflection of light. So the applications are like this. Optical fibers are used in telecommunication. Of course, total internal reflection happens in optical fibers, and of course they are used in telecommunication. They are used in decorative table lamps. They are used in endoscopes to view the interior part of the human body. Like this, as this is the 3 mark question, 3 points are required to obtain 3 marks. And 25th. So the 25th question, give 3 characteristics of photons. Look here. Photons are electrically neutral. Photons travel with the speed of light. The rest mass of photons is 0. The energy of each photon is given by E is equal to h nu. Nu is there. Momentum of the photon is given by P is equal to mc. Radiation consists of packets of energy called photons. So number of photons may not be conserved in a collision. Look here, of course there are 7 points, but only 3 points are enough. Any 3 points are enough. So next it is 26th. Look here. Of course 1, 2, 3, 4, 5 questions we have written. Enough, and these 3 are choices. They have to be answered after answering all the questions. But now I am going to answer. For 26th, how is Zener diode used as a voltage regulator? So look here, this is the circuit diagram of the Zener diode. Zener diode connected in series with some resistance Rs. And between free end of Rs and free end of this Zener diode, input is taken. That is unregulated voltage. And of course, the load is connected between the terminals of the Zener diode. This is the circuit. The circuit connections are made as shown in the figure. The circuit contains a Zener diode, a unregulated voltage source, a series resistance Rs, and a load resistance RL. Any change in the input voltage results in change of voltage drop across Rs without any change in voltage across Zener diode. Suppose any change in voltage occurs, that appears here, not here. Across this, constant voltage remains. And look here, thus the Zener diode acts as voltage regulator. So this is the answer. So for this one, look here, we get 1 mark for this figure and 2 marks for explanation. So then part D, answer any 2 of the following questions. These are 5 mark questions. 2 into 5, it is 10. There are 3 questions. Out of these 3, only 2 have to be answered. These 3 questions are selected from part 1 of the physics. Let us see this 27th question. State Gauss law in electrostatics. Using the law, derive an expression for electric field due to uniformly charged thin spherical shell at a point outside the shell. So first let us state the Gauss law. The total electric flux through a closed surface in free space is equal to 1 by epsilon naught times the net charge enclosed by the surface, where epsilon naught is absolute permittivity of the free space. So according to Gauss law, pi, that is flux, is equal to 1 by epsilon naught q. Q is the total charge, of course. Consider the diagram. Look here, this is the charged shell of a conductor. This is the charge uniformly distributed on this shell. Let R be the radius of this conductor. O is the center. Consider a point P at a distance of R from O. So imagine a spherical surface of radius R and center O. This is the Gaussian surface. Consider a surface area around this point. So the surface area is delta S. It is taken as vector. The direction of this surface area is parallel to the direction of electric field at this point. So now let us derive an expression. Q be the charge uniformly distributed over surface of the shell. The electric flux through the Gaussian surface is given by here. Pi is equal to sum of E delta S cos theta. E electric field at this point, delta S surface area, and theta is the angle between electric field and this surface area. This angle, as these two vectors are parallel, the angle is 0. Therefore, cos 0 is 1. This equation becomes pi is equal to sum of E delta S into 1. Of course, cos theta is 1. Electric field at any point on the Gaussian surface is same. It is constant. Therefore, summation applies for delta S. Take this E outside. That is E into sum of delta S. Now, according to, look here, sum of delta S is nothing but sum of the area of this Gaussian surface. It is given by 4 pi r square. Substitute for this one. That is pi is equal to E into sum of delta S is 4 pi r square. Take this as equation 3. From Gauss law, pi is equal to Q by epsilon naught. From equation 3 and 4, left hand sides are equal. So we can equate right hand sides. It is like this. E into 4 pi epsilon naught square, 4 pi r square is equal to Q by epsilon naught. Cross multiply this 4 pi r square. E is equal to Q divided by epsilon naught into 4 pi r square. Modify 1 by 4 pi epsilon naught and Q by epsilon naught, Q by r square here. This is an expression for electric field at a point. The direction of E is along OP. Look here in this direction. Now let us see scheme of valuation for this question. Look here, for the statement there is 1 mark. For this correct diagram, 1 mark. And up to this point, that is pi is equal to E into 4 pi r square, 1 mark. And for Gauss law, it carries 1 mark. And final expression 1 mark. Totally 5 marks. So now let us go for the another question 28. The question 28 is, with the help of circuit diagram obtain an expression for equivalent resistance of two resistors connected in parallel. Look here. So 28, with the help of the circuit diagram obtain the expression for equivalent resistance of two resistors connected in series. Of course it is parallel. By mistake I have taken series. If I do this thing, I get no mark. Okay. And one more thing, we don't have to write this question again on the answer paper. Just it is enough to write the question number. Consider the circuit diagram. Look here, these two are in series and its equivalent resistance is Rs. Resistor A, resistor B, R1, R2 are the resistances. A battery of voltage V is connected and this is the equivalent circuit. As this is series, current flows through this one I. This I through R1 is equal to I through R2. So now for this parallel combination, applied potential difference is equal to V1 plus V2. According to Ohm's law, V1 is equal to IR1, V2 is equal to IR2. Substitute here for V1 and V2. That is I R not R dash, it is R1 plus IR2. So V is equal to I into, this I is common, R1 plus R2. And for the effective resistance Rs, we get V is equal to I into Rs from the figure 2. So look here, this equation is 3 and look at 2, V. Left hand sides are V, equate right hand side. We get I into Rs is equal to I into R1 plus R2. I gets cancelled and Rs is equal to R1 plus R2. This is an expression for equivalent resistance in the case of series combination. But actually the question given is parallel combination. Even though this derivation is correct, As this is not an expression, not correct answer for the given question, it carries no mark. Now let us discuss the 29th. Look at 29. Derive the expression for magnetic field at a point on the axis of a circular current loop. So now let us consider the diagram. Look here, this is the circular loop. Current flowing through this one is I in this direction. Let R be the radius of this loop, and alpha, look here, this is the radius, and consider this is an axis. This is the point P at a distance of x from O. At this point, of course, the magnetic field due to current element at the point Q, let the part of the circular loop is current element. Current element is treated as a vector. Its direction is like this. Its length is dl. So magnetic field at this point due to this current element is in this direction. This is dB. This angle is alpha. Therefore this angle is also alpha. Now the component of this dB along this x-axis is given by dB cos alpha in this direction. Along y-axis it is dB sin alpha, but we need only magnetic field along x-axis because y components get cancelled. So now let us look here. According to the law, dB is equal to mu naught by 4 pi I into dl cross r. So this r, this one, this vector, and dl is this vector. Of course dl and r, they are perpendicular to each other. Angle between them is theta. So this is the vector form. Now of course here also there should be a vector arrow mark is there. Now the magnitude of this one is given by mu naught by 4 pi I dl sin theta by r square. So where this theta is the angle between the direction of dl and r, this dl and r. So next theta is equal to 90 degree because dl is perpendicular to r. Therefore sin 90 is 1. This equation becomes dB is equal to mu naught by 4 pi I dl by r square. Take it as equation 1. And next the magnetic field dB is resolved into two components along x and y axis. Along x axis dB cos alpha, along y axis dB sin alpha. So y component of dB will be vanished, but x component of dB are added up. Magnetic field at P due to loop is given by B is equal to sum of dB cos alpha. This one, this is dB cos alpha. This has to be summed like this. So B is equal to this much. From equation 2 and 3, this is 2. Equation 3 for dB, that is mu naught by 4 pi ideal sin theta by r square. So look here, for dB summation of mu naught by 4 pi ideal by r square and cos alpha is there. So B is equal to, here mu naught 4 pi I r square, all these are constant, therefore take outside the summation symbol. Cos alpha is also constant, take it outside. This summation applies only for dl. Summation of dl means addition of lengths of the elements. Look here, dl plus dl plus dl. So when all these dl's are added all around the circumference, it gives length of the circumference. So sum of dl is circumference, and from the triangle POQ, look here, cos alpha is equal to adjacent divided by hypotenuse, r by r, capital R by r. So now we get sum of dl, summation is 2 pi r, and now B is equal to mu naught by 4 pi I by r square, sum of look here, summation is 2 pi r, and cos alpha is r by r. So it comes 2 pi r IR. Look here, 2 pi r I into r. Here we have taken r square. Okay, this like this, mu naught by 4 pi 2 pi I r square. r into r square into r cube. So from triangle POQ, look here, PO, this is OQ, this r square, look here, this is the right angle triangle. This r square is equal to x square plus r square. Look here, r square plus x square. And here r is equal to, this 2 is transposed this side, it becomes square root, that is half. So in this equation, this becomes r square plus x square whole to the power of 3 by 2. So from the thin circle, for the thin circle of n turns, of course this expression is for this single turn. If this contains n number of turns, then n has to be multiplied here. Therefore b is equal to mu naught by 4 pi 2 pi I r square, here n is taken, number of turns, divided by r square plus x square whole to the power of 3 by 2. So this is an expression for magnetic field at a point due to current carrying circular loop. So here the scheme of valuation is like this. For this diagram, 1 mark, and for this dB is equal to mu naught by 4 pi ideal by r square, for this equation it is 1 mark, and for the explanation it is 1 mark. It means here y components are cancelled, x components are added, are there, and b is equal to mu naught by 4 pi I by r square cos theta summation of dl, this carries 1 mark, and for final expression it is 1 mark. So next let us discuss the question number 30. Fifth one, answer any two of the following questions. In this part there are 3 questions, 30, 31 and 32, but only 2 have to be answered, one is choice. These 3 questions are selected from second part of physics, second PC physics. They are 5 mark questions, therefore 2 into 5 is equal to 10. Let us see this 30th one. Obtain the expression for fringe width in the case of interference of light waves. So now this is the diagram. S1 and S2 are 2 slits. They are separated by a distance d. And this is the screen to obtain the fringe pattern. This is at a distance of d from these 2 double slits. Q is midpoint between S1 and S2. O is the midpoint of the fringe system. Consider a point P at a distance x, at which a bright fringe is there. Now let us draw S1P. This is one light ray. Arrow mark should be there. S2P. This is the another light ray. Therefore, there should be another arrow mark. Join QP like this. So now let us obtain an expression for it. So here, look here, draw S1N perpendicular to S2P. Look here, S1N perpendicular to S2P. Here path difference. Look here, from here to here, this S2P is the path difference, that is equal to S2N, that is equal to S2P minus S1P. S2P, this ray, this path minus this path, S1P. So here the angle, this angle is equal to this angle. Now from the triangle NS1 S2, here N S1 S2, this is the right angled triangle. Here tan theta, sorry, sin theta is equal to delta x by d, because sin theta is equal to opposite divided by hypotenuse. Opposite delta x, hypotenuse is d, small d. Take it as equation 1. And from triangle POQ, this right angle triangle, here let us take tan theta, because opposite and adjacent we know. Opposite is x, adjacent is d. So here tan theta is equal to x by d. Take this as equation 2. So now for small values of theta, look at this point P is very close to O, therefore this angle theta is very small. For small angle sin theta is equal to tan theta. This is because sin theta is almost equal to theta and tan theta is also almost equal to theta, therefore they are equal. By equating the right hand sides of this 1 and 2, so we get x by d is equal to delta x by d. Cross multiply this one, we get x is equal to d delta x by d. Take it as equation 3. For nth bright fringe from the central bright fringe, look here, from here to this thing for nth one, this x is taken as xn, and this delta x, as it is bright fringe, the condition for path difference is n lambda. Substitute for this equation, we get xn instead of x, xn. Here instead of delta x, it is n lambda. So take it as equation 4. And for one more, n plus 1th fringe, this xn can be written as xn plus 1 for n plus 1th fringe. This is n plus 1, and delta x is equal to n plus 1 lambda. Substitute here, you get xn plus 1 is equal to d instead of n plus 1 lambda divided by d. Take it as equation 5. The fringe width beta is equal to xn plus 1 minus xn. Therefore, beta is equal to, in the place of xn plus 1, d into n plus 1 lambda by d, and in the place of xn, dn lambda by d. And here d lambda by d take common. So n plus 1 minus 1. Minus and plus 1 get cancelled, and we get 1. Therefore, beta is equal to d lambda by d. So beta is equal to d lambda by d. This is an expression for fringe width. So here we get marks for this diagram with explanation, 1 mark. And next, for this condition, that is delta x is equal to n lambda, this carries 1 mark. And for this one, beta is equal to xn plus 1, this carries 1 mark. And remaining steps carry 1 mark, totally 5 marks. So now let us go to 31st question. It is like this. Write 3 postulates of Bohr. Mention 2 limitations of Bohr model. Here for 3 postulates 3 marks, 2 limitations 2 marks, totally 5 marks. Therefore, so the first postulate, the electron revolve only in certain orbits called stationary orbits without the emission of radiant energy. Second one, the angular momentum of an electron in the stationary orbit is an integral multiple of h by 2 pi. The angular momentum L is equal to integer n into h by 2 pi, where n is 1, 2, 3, etc. Here, of course, h is Planck's constant. Third one, an electron emits energy only when it jumps from outer stationary orbit to inner stationary orbit. If E1, this is E1, this is E2, are the energies of an electron in the inner orbit and outer orbit respectively, then energy of the emitted photon is given by E is equal to E2 minus E1, but E is equal to h nu, therefore h nu is equal to E2 minus E1. These are the 3 postulates. Now limits. Number 1, Bohr's theory is applicable only to hydrogen and hydrogen-like atoms. It could not explain the fine structure of spectral lines. Look here, this 3 plus 2, n of 2 get 5 marks. But one more point we can write for the safety side. Third one, it could not explain elliptical orbits of electron. So this is an answer. Next, let us go to 32nd one. So the 32nd question, explain the formation of energy bands in solids. On the basis of energy bands, distinguish between a metal, a semiconductor, and an insulator. So look here, first let us discuss the formation of energy band. In an isolated atom, that is free atom, the energy levels of electrons are well defined. Single lines are there. In solids, nucleus of each atom interact with the electrons of the neighboring atoms. Also, valence electrons of different neighboring atoms interact with each other. Due to this, energy levels are slightly altered. these different energy levels with continuous variation are called energy bands. So mainly there are two types of energy bands. They are valence band and conduction band. So this is formation of energy band. For this carries 1 mark. So look here, the gap between the top of valence band and bottom of conduction band is called energy band gap, EG. Now let us distinguish. Consider valence band and conduction band. They are overlapped. This is in the case of metals. Valence band and conduction band, there is a small gap. This gap is less than 3 electron volt. This is for semiconductors. So this is valence band, conduction band. There is a large gap. Its energy is greater than 3 electron volt. This is for insulator. Now for conductors, in case of conductors or metals, valence band and conduction band are overlapped. Eg is equal to 0. Conduction band is slightly filled with electrons above 0 Kelvin temperature. Semiconductors. In semiconductors, the valence band and the conduction band are separated by small energy gap. Eg is less than 3 electron volt. Conduction band is partially filled with free electrons above 0 Kelvin temperature. Insulators. In insulators, the valence band and conduction band are separated by large energy gap, that is greater than 3 electron volt. Conduction band is completely empty above 0 Kelvin temperature. So here the scheme of valuation is like this. Look here, for the 1 mark, for every point 1 mark. Formation of energy, it is 1 mark. For this diagram 1 mark, and for 3 differences 3 marks. 3 plus 2 5 marks. So next let us go to the 33 part 6. This is actually problem part. In this part there are 5 problems: 1, 2, 3, 4, 5, 33, 34, 35, 36, 37. Answer any 3 of the following questions. 2 problems are choice. Each carry 5 mark. 3 into 5, it is 15. Let us discuss the 33rd problem. In a parallel plate capacitor with air between the plates, each plate has an area 6 into 10 to the power of minus 3 meter square, and the distance between the plates is 3 millimeter. Calculate the capacitance of the capacitor. If the capacitor is connected to 100 volt supply, what is the charge on each plate of the capacitor? Absolute permittivity is given. It is 8.85 into 10 to the power of minus 12. So now consider the problem again. Of course, it is not necessary to write the problem in answer paper. Just to take the data, I have considered it. Look here, in parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power of minus 3 meter square. So that is, area is equal to 6 into 10 to the power of minus 3 meter square, and the distance between the plates is 3 millimeter. D is equal to 3 millimeter. So we have to write data, every physical quantity in one system, that is SI system. So 3 millimeter can be written as 3 into 10 to the power of minus 3 meter. Calculate the capacitance of the capacitor. C is equal to what? If the capacitor connected to 100 volt, this capacitor connected to 100 volt supply, what is the charge on each plate? Q is equal to what? And epsilon naught is given. So for this, the formula is C is equal to epsilon naught A by D. This is the formula for capacity of parallel plate capacitor. We know epsilon naught, we know A, and D. This is substitute for it, and this can be calculated by using simple calculator. Scientific calculator is not allowed to enter into the examination hall, so you are allowed to bring scientific simple calculator. So using that simple calculator, C is calculated. It is equal to 17.7 into 10 to the power of minus 12 farad. In the next part, if this capacitor is connected with a potential difference of 100 volt, what is the charge? So for this, definition for capacity, C is equal to Q by V. V is cross multiplied. So Q is equal to C value is 17.7 into 10 to the power of minus 12 into 100. When it is multiplied, it gives Q is equal to. So this is the value for Q. And here it is very important to note that for this physical quantity, it is essential to write the answer. It is essential to write the unit. If unit is not there, this will not carry its mark. Now let us see schema of valuation. Look here, for this formula 1 mark is given. For the substitution 1 mark is there, and for this one the answer 1 mark is there, and for another formula 1 mark, and the value of Q, that is C, for this there is 1 mark. So if this C, that is unit, is not written, you will get 0 here. You will not get this mark. So you have to aware of this unit. And here, if you don't write this formula and directly substitution and all the steps are done, then also you will get 0 mark. So you must start from this formula and then substitution, then calculation, like this. So now let us discuss the 34th one. 34th, a battery of internal resistance 3 ohm is connected to 20 ohm resistor and potential difference across the resistor is 100 volt. If another resistor of 30 ohm is connected in series with first resistor and the battery again connected to the combination, calculate the EMF of the terminal potential difference across the combination. So now let us take this problem. A battery of internal resistance 3 ohm. Internal resistance is represented by small r. Case 1. Look here, this is the battery of internal resistance R, EMF E, and the resistance is R, current I flows. 3 ohm is connected to 20 ohm resistor. Look here, this is the 20 ohm resistor, and potential difference across the resistor is 100 volt. Across this it is 100 volt. It is not 100, it is 10 volt. 10 volt only. If another resistor of 30 ohm is connected in series with the first resistor and the battery again connected to the combination, let us consider another this one. With R1, a resistor R2 is connected in series. The same battery is connected here. What is the voltage across this combination, that we have to calculate? So here internal resistance R is 3 ohm, the resistance R1 is 20, V1, this voltage is 10, E is equal to EMF is equal to what, and V2 across this, what is the terminal potential difference, this we have to calculate. So we know I is equal to E divided by R1 plus R, but I is equal to, according to Ohm's law, I1 is equal to V1 by R1. So V1 by R1, we need E, cross multiply this one, we get E is equal to V1 R1 plus R divided by R1. V1, substitute for V1, 10, for R1 it is 20, for small r it is 3, and again 20. So this one, this can be calculated by using simple calculator. E is equal to 11.2 volt. The unit of EMF is volt. Now in the case of second one, let us calculate V2. Here given, of course, internal resistance, the same battery is connected, therefore internal resistance is 3 ohm. R1 is 20 ohm, R2 is 30 ohm. So E is equal to 11.5 volt. V2 is equal to what? The same formula once again we have to consider, but for this one it is I2 is equal to E divided by R3. R3 means the effective resistance of these two resistors. It is nothing but RS plus R. So here we know I2 is equal to V2 by RS, and E divided by, that is equal to E divided by RS plus R. This RS is nothing but equivalent resistance of resistors connected in series. That is, of course, Vs, V2 is equal to V2 or Vs, voltage across the series combination. So this RS is cross multiplied here. like this, E RS divided by RS plus R. So here RS series combination is equal to R1 plus R2. R1 is 20, R2 is 30, that is equal to 50. Now substitute for this one. Vs or V2 is equal to 11.5, this one, 50, this one, and 50 plus 3. So this V2 is equal to 10.84 volt. So this is the problem 34. Now let us discuss the problem 35. So here calculate resonant frequency and Q factor of series LCR circuit. So here in series LCR circuit containing pure inductor of inductance 3 Henry, capacitance 27 microfarad, it is nothing but 27 into 10 to the power of minus 6 farad, and resistor of resistance 7.4 ohm. R is equal to 7.4 ohm. So here we have to calculate resonant frequency FR and Q factor Q. So here we know F is equal to 1 over 2 pi root LC. This is the formula for resonant frequency. Substitute values for L and C. We get 3 into 27 into 10 to the power of minus 6. This can be calculated by using simple calculator. FR comes this much. So FR is equal to 17.68 Hz. Okay, now the formula for Q factor, that is omega naught L by R, where omega naught is resonant frequency, resonance angular frequency. So this omega is nothing but 2 pi f. Therefore 2 pi f L by R. This is resonance frequency. Substitute for all this. Q is equal to 2 into pi, that is 3.14, f frequency 17.68, and L is equal to 3 Henry divided by R is equal to 7.4 ohm. So the value of Q comes 45. So this is 35th problem. Now let us discuss 36th problem. So here the 36th problem in the question paper. Look here, two lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Find the focal length of the combination. Calculate powers of two lenses and combination. So look here, in this one, two lenses of focal length 0.2 and 0.3. Okay, look here, 0.2 and another one 0.3 kept in contact. Find the focal length of the combination, effective focal length, and power P1, power P2, and effective power P. This we have to calculate. We know for two lenses in contact, 1 by f is equal to 1 by f1 plus 1 by f2. Therefore f is equal to f1 f2 divided by f1 plus f2. f1 f2 f1 plus f2. Reciprocal of it is f1 f2 by f1 plus f2. Substitute for f1 f2. We get this much, and therefore f is equal to 0.06, multiplication of this one, addition of this one. So f is equal to 0.12 meter. This is the focal length of the combination. Now the power, we know power is reciprocal of the focal length, that is P1 is equal to 1 by f1, that is equal to 1 by 0.2, 1 by 0.2, that is equal to 5d. Here one important thing we have to keep in memory. In order to find the power, the focal length must be in meter. That is very important point. Next, P2 is equal to 1 by f2. This is f2. f2 is 0.3. So 1 by 0.3 is equal to 3.33d. Next, for P, it is 1 by f, that is equal to 1 by 0.12. That is equal to 8.33. 5 plus 3.33 is 8.33d. So d is diopter, unit of power. So this is the problem 36. Let us see the scheme of valuation. Look here, 36th one. For this formula 1 mark, and for the answer it is 1 mark, and P1 5d 1 mark, for calculating P2 it is 1 mark, for P it is 1 mark, and finally effective power, for that it is 1 mark. Totally 5 marks are there. Next let us discuss the problem 37, last one. So here, look here, calculate the binding energy and binding energy per nucleon in mega electron volts of a nitrogen nucleus, that is N714, from the following data. Mass of proton is equal to 1.00783 units, mass of neutron is equal to 1.00867 unit, and mass of nitrogen nucleus is equal to 14.00307 unit. So now look at this. From this, calculate the binding energy and binding energy per nucleon. This one, for this data is given: mass of proton, mass of neutron, mass of the nitrogen nucleus, that is M is equal to so much. And from this we can calculate mass defect, binding energy and binding energy per nucleon. Look here, A is equal to 14. Here A is the mass number 14, 7 is the atomic number, Z is equal to 7. So now to find the mass defect delta M is equal to ZMP plus A minus Z into Mn minus M. Z, that is 7, MP, look here, this much mass of the proton. So now this comes A minus Z, 14 minus Z, into mass of the neutron, look here, this much, minus mass of the nucleus, look here, this much. So this comes so much when it is multiplied, and we get finally 0.11243 units, atomic mass unit. So this is the mass defect delta M. By knowing this one, we can calculate binding energy. According to Einstein's equation, binding energy is equal to mc square. Here mass defect delta M c square. Delta M is this much, c is velocity of light, 3 into 10 to the power of 8, like this. And of course we know the binding energy of 1 AMU is equal to 931.5, 931.5, 1 into 931.5 mega electron volt. Therefore for this much mass defect, binding energy is given by 0.11243 into, here into is there, 931.5 mega electron volt. So this is equal to 104.7285 mega electron volt. So this is binding energy. To calculate the binding energy per nucleon, this has to be divided by mass number, that is binding energy divided by mass number, that is equal to 104.7285, this much, divided by mass number is 14. This gives 7.4806 mega electron volt. So this is the binding energy per nucleon. Of course here it is asked in mega electron volt, it's okay. If it is asked in joules, it has to be converted. So this is the problem 37. Let us see the scheme of valuation. Look here, for this delta M, formula for delta M, 1 mark. Calculation of delta M, for that 1 mark. And for binding energy formula are saying 931.5 mega electron volt is equal to 1 AMU, that is 1. And for binding energy of nitrogen is so much for this 1 mark. And binding energy per nucleon, the formula substitution calculation gives 1 mark. So this is a 1, 2, 3, 4, 5 marks are obtained. So this is about the question paper to March 2014 physics. So now this is the front page of the main booklet, main answer booklet. Government of Karnataka, Karnataka State Pre-University Education Examination Board, second year PUC examination. Look here, in this box, this number is the booklet number. Here, this box is provided to enter all ticket number or register number. Look here, subject code. For physics, it is 33. So these are the numbers of additional sheets. Look here in this box, the total number of pages in main book, total number of additional sheets taken, and here the total of these two. 24 plus 3, it is 27. Look at this table. This table is provided to enter marks obtained. So look here, this is question number 1, question number 2. Like this, there are 80 boxes, but in physics only 37 questions are there, therefore only 37 boxes are used. So for every question there is only one box like this. So this is question number 1, marks allotted for question number 1, marks obtained for the answer of question number 1. Question number 2 and the marks obtained like this. So as there is only one box for each question, if the student has written answers twice or thrice for the same question and same answer, he has got 1 mark in different places of the answer sheet. All the 3 marks are not counted, because for example question number 3, there is only one box, all the 3 marks have to be entered here. Out of 3 only 1 is considered and other 2 are rounded as extra. Of course from 1 to 10 1 mark questions. Look at these 2 mark questions from 11 to 18. 18 questions are there, but answer any 5 of the following. But in this case the student has answered 1, 2, 3, 4, 5, 6. Only 5 are needed, therefore 1 is rounded off. A question for which he has obtained minimum mark is rounded. Maximum marks are added or considered. So like this, marks are allotted in these boxes. For this row, look here, this is the sum of all this, and this is the sum of all this. This one is sum of all these marks. Like this, sum of all these marks is this one. So this is the total marks out of 70. So this is about how evaluator enters marks into the boxes and how he counts. In the clip I have explained how to answer the questions in 2014 physics question paper, and for all other previous year question papers, solutions are there in this book. This is the Legend study material, easy path to success, second PC PCMB combined, and this is published by Madanagopala Publications, Bangalore. So this contains solutions for all previous year question papers, not only for physics, for chemistry, maths, and also biology. And also there is one more book, that is this one. This consists of solutions for Kannada and English previous year question paper. You can purchase this book. It is available in shops.